Hello, in this video we're going to work through a function represented by a formula that also has an application attached to it. So in the context of this problem, we're going to figure a couple of things out and explain their meaning. Okay, so our function is this w of t that we see sitting here, kind of messy, and it is giving us the weight in pounds of a large breed dog t years after birth. So t is the age of the dog in years, and w of t is the weight of the dog in pounds. First thing we're supposed to do is find w of 2 and explain its meaning using everyday language. So w of 2, this function takes whatever we give it and plugs it in right here. So the rule is it's going to take 10 plus 100 times 1 minus 1 over 1 plus our input squared. Our input was 2, so 2 squared is 4. And you can distribute or do whatever you want here, but I think I'm going to actually go ahead and just crunch through what's in the parentheses. So I see a 1 minus 1/5, which is, see if I can squeeze it in here, 4/5. 4/5 of 100 is going to be 80. So it's looking like w of 2 is 10 plus 80, or 90. And then we're supposed to explain what this means using everyday language. Okay, so input output. Our input was 2. This should be the dog's age in years. Our output was 90. This is the dog's weight in pounds. So at 2 years old, the dog weighs 90 pounds. Okay. Part B is asking us to solve w of t equals 60 and explain the meaning of our solution using everyday language. All right, so now we're being asked to use 60 as the output. So we're going to set 60 equal to the 10 plus 100 times 1 minus 1 over 1 plus t squared. Okay, again, you have some choices on order here. You could deal with parentheses first. I think what I'm going to go for is I'm looking at this and I see that we just have one lonely t on the right-hand side. So I'm going to see how far I can get using reverse order of operations. So again, if you have any confusion here, you can think about if I picked a number, plugged it in for t, and crunched through this, what's the last thing that would happen? And that's the first thing you should get rid of. So if I picked, say I picked t equals 1. I would square it, I would add 1 to it, I would do 1 divided by that, 1 minus whatever I've got, I would then multiply by 100, the last thing I would do is add 10. So the first thing I'm going to do to solve is subtract 10 from both sides. Okay. Next, I need to get rid of the 100. That was the second to the last thing happening. I multiply the whole thing by 100. So I'm going to divide both sides by 100. 50 over 100 is 1/2. Again, not the only way to do this, but it actually is working out fairly nicely so far. The next thing I need to do is get rid of the 1. There is a subtraction here, but the thing that's being subtracted is the 1 over 1 plus t squared. So if we want to get rid of the 1, we want to think of this as negative 1 over 1 plus t squared plus 1. And to get rid of a plus 1, we need to subtract it from both sides, which is going to leave us with negative 1/2 equal to negative 1 over 1 plus t squared. Okay, at some point we're going to need to clear fractions. I'm going to go ahead and do one more step before I clear the fractions. I'm going to say if I have this minus 1 out in front, I can wipe it out just by multiplying or dividing both sides by negative 1, and I get positive 1/2 equals 1 over 1 plus t squared. Okay, so this one gets a little bit funny because we're not dividing t by something, we're dividing something by an expression involving t. So it really does come down to how do we get the t out of the denominator? And the answer is we multiply both sides by 1 plus t squared. And I think I'm going to go ahead in the same step and just clear fractions completely. So I'm going to multiply both sides by 2 times 1 plus t squared. So on the left-hand side, I can cancel the 2's, and I'm just left with a 1 plus t squared. On the right-hand side, I can cancel the 1 plus t squareds, and I'm just left with 2's. Again, this has got a lot going on in this equation, so there's absolutely different ways to do this. If something else jumps out at you, go ahead and pause and work it your way and see if you can come up with the same answer. Ooh, I'm almost out of room, but I think I can squeeze it in. Almost done. Now I've got t by itself on the left-hand side, so I'm going to get rid of the 1. I need to subtract 1 from both sides. And then I need to get rid of the square. I'm going to square root both sides. Do not forget your plus or minus. The square root of 1 is just 1. Feel free to skip writing that down, but make sure you're really clear on the fact that I did square root this. So t could equal positive or negative 1. I think we should have a pretty good idea of a reasonable domain here. We don't want to talk about a dog being negative 1 year old. So I would say that what we've just figured out is that t equals positive 1 is the good solution, meaning the dog will weigh 60 pounds at age 1 year. Squeeze it in here. The dog weighs 60 pounds at 1 year old. Okay. A little bit squashed. Last part here is growth rate. Find the growth rate from age 3 to 6. Okay, so this is an average rate of change question, which means we basically need 2 points. So let's figure out what W of 3 and W of 6 are. Okay, so W, it's going to do 10 plus 100 times 1 minus 1 over, okay, and I'm going to do a little in my head here. If we're plugging in 3, if our input is 3, we'll get 3 squared, which is 9, plus 1, which is 10. So I see 10 plus 100 times 9/10. Okay, so 10, 90, looks like we're getting 100 from this thing. So 9/10 of 100 is 90. When we add 10 on, we get 100. Okay, let's check out what happens when we plug in a 6. We get 10 plus 100 times 1 minus 1 over. Okay, if our input is 6, we get 6 squared, which is 36. So 37. 10 plus 100 times 36 over 37. And that one doesn't work out quite so nicely, so I'm going to go ahead and convert it to a decimal. 10 plus 100 times 36 over 37. And we're getting approximately 107.297. So let's go 30. All right, so if we want to calculate average rate of change, we need change in y over change in x. So this one, we're going to take the 107.3 minus 100 over change in input, 6 minus 3. Okay, so we have a 7.30 approximately over 3. All right, and in my calculator, I went ahead and didn't do the rounding. I kept it as 107.297, blah, 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 and just kept my work in here. So 7.297, blah, 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 and then divide, and I get approximately 2.43. Okay, and I didn't ask you to explain using everyday language, but I always want to see units. So in this one, we want to think very carefully about what this means. So again, it's a slope calculation. We get change in output on the top, so this is change in W. And we get change in input on the bottom, change in T. So if we're thinking about this as change in weight over change in time, this is saying that from age 3 to age 6, the dog's weight increased by 2.43 pounds per year on average, a total of 7.3 pounds in 3 years, which is approximately 2.34 pounds per year. All right, that's it for this one. Thanks for watching.